Hello students, so let's go for a quick revision for quantum mechanics. The first quick revision will be for the postulates. So in a postulates, you have to remember all the 5 postulates, but you can avoid postulates 4. Just you can remember it just with a uh, theory, but you have to learn how to apply postulates 1, 2, 3 and postulates 5. So let me straightforward go to our postulates and which type of question will come from here. So the first postulates is nothing but the state psi. So you have to always keep in mind that this state psi is some can written as a wave function psi in one dimension, it is function of x, and you have to also know that psi star psi is nothing but your probability density. This is your probability density, and this is nothing but mod psi square. And if you want to calculate mod psi square dx between a to b, then what is meaning of that? Meaning of that, you want to going to calculate probability such that particle is between a to b, and obviously you have to ensure that it is normalized. If it is not normalized, then you have to just focus on this particular part and you have to just go from minus infinity to plus infinity. So this is very important. Most of people are not checking whether it is normalized or not. So I will just tell you that use this particular thing. The second postulates will tell you, this is your first postulates, and yes, first postulates will all about the superposition. So you can remember the state plus state is equal to state. It may be some theoretical question, and all of you can take the normalized wave function because you are talking about the probability. The second postulates is all about measurement, and the measurement is eigenvalue, the operators which is associated to any physical quantity. So we have learned all these things. So second postulates in a one liner, I can write a phi n is equal to an phi n, and this is my eigenvalue, and this is the actually physical measurement. This is physical measurement, and this is my eigenstate. So you have to always keep in mind that every state is not an eigenstate. So this is your eigenstate, this is eigenvalue, and this is operator. This is operator, and obviously this is Hermitian operator, and it is associated to some physical quantity. Some physical quantity. So obviously from here you can learn what will be the measurement. So measurement is eigenvalue. This is very conceptual. You have, whenever something is, somebody asks you what will measurement, you have to go for operator and calculate the eigenvalue and eigenstate, and you have to always keep this eigenstate as a unit vector. That means you have to normalize it and all, and you have to take the basis as a orthonormal. So what is meaning of that? Any state can be written as summation over Cn phi n. So any state can be written as a basis of basis of phi n, and this Cn, you know how we can calculate this particular value of Cn. This Cn is nothing but you can know a scalar product between phi n and psi. So this is very important thing. You can use it as a ket, you can use it as a vectors, you can use it as a column matrix, and you can also use it as an integration function. So this is phi n star psi x dx. So this is the value of Cn. So you have to always keep in mind this particular thing. So this is all about postulates 2. The postulates 3 will be written as probability of measurement of an, probability of measurement of eigenvalue an is equal to the basically phi n psi, and you have to take mod square, and this will be your psi and psi. and you can use as a integration form, you can use as a ket form, depends on which kind of problem is given. So always try to figure it out. This is nothing but the scalar product. If I am talking about the scalar product, that means I am talking about some, let's say if I am talking about phi and psi, that means I am talking about phi and psi. That means I am talking about minus infinity to plus infinity, phi and star psi dx. So you have to do this thing, you have to do practice on this particular thing. So this is your probability of measurement of an on state psi, and phi n is the eigenstate, which is normalized eigenstate. So which is normalized eigenstate, suppose with the eigenvalue an. So this is your third postulates. This is very important postulates, and if you are going to use this third postulates, then you can easily calculate average values. You can easily calculate average value. So average value you can calculate in many way. You can just use this formula also. Psi is psi, psi. You can use as a integration. If a is some variable which is continuous, then you can go for psi star a as a some function of x, psi x, and you have to write a as a x in a x notation. As a x basis, you have to go for minus infinity to plus infinity, and you can also this write psi star psi dx minus infinity to plus infinity. For example, for position, you can just use this formula because it is position is the continuous thing. Sometime this you can use directly probability method, and which will be nothing but an probability of getting an summation over n. Similarly, you have to calculate a square, and this a square can be written same way, and either in continuous fashion or in discrete fashion. So what is your a square? You can easily calculate a square, and this a square is psi a square psi upon psi psi. If outcome of a square is discrete, then you can use this formula also. An square probability of getting an, this is n. And if it is continuous, then obviously you have to go for integration form, that is ax square psi x dx, obviously from minus infinity to plus infinity, and you have to go from minus infinity to plus infinity psi star psi dx. And the delta a you can easily calculate. The delta a is expectation value of a square minus average value of a whole square. You have to always make sure, that a average of a square must be greater than or equal to average of a whole square. So this is in general operators, in general postulates 1, 2, 3, and postulates 4. You know, after the measurement of psi, if you will get eigenvalue an, then your state psi after the measurement is proportional to nothing but phi n. But I don't think that this question will come into your JAM examination. It can come into other TFR or all other exam, but obviously you have to focus on this type of calculation, how you are going to calculate all this thing. But most important thing is that all about the fifth postulates. That means I am talking about Schrodinger wave equation. So let's go for what we have to learn into Schrodinger wave equation and why it is so important. So let's go for our next thing into postulates part. So you have to learn for the Schrodinger wave equation. Here we have h phi n is equal to I h cat del phi n upon del t, and h phi n in this is equal to nothing but en phi n, and where this en is equal to your basically this en is nothing but the energy eigenvalue. So we have just done all the derivation, how you can write the derivation and do this derivation, but I'm not going to derivation part. So Hamiltonian has two purpose. The first purpose is measurement of energy. Measurement of energy. And second purpose, it will just tell you time evolution. Time evolution. Time evolution of state. So for the measurement of energy, you know Hamiltonian, you know energy eigenvalue, and you know energy eigenstate. So everywhere you have to solve the time independent Schrodinger wave equation, and you can talk about the energy eigenvalue and eigenstate. But how you can go for the time evolution of state? So suppose I have psi, and this psi is written in a basis of energy eigenstate. So this psi is written in a basis of energy eigenstate. I assume this is energy eigenstate, something like this. Then this is at t is equal to 0. Then at t is equal to t, you should know that this number is going to change, I, and this is energy eigenvalue. En is the energy eigenvalue, and similarly you can go Cm e to the power minus I Em T upon h cut phi m. And what is En and Em? H phi n is equal to En phi n, and you know H phi m is equal to Em phi m, and we have basically phi n phi m as orthogonal basis. So this is very important. This is time evolution. In this time evolution, you have to remember two conditions. That first condition is that after what time psi t is orthogonal to psi 0? So psi t is orthogonal to psi 0. That means this should be 0, and you should use this particular concept. And you remember we can get one formula also, and I can write this formula here. So this formula is basically given as, you can write, this is basically, let me check what is this formula. This formula is T is equal to h cut upon mod En minus Em, and we have cos inverse minus mod Cn square upon mod Cm square. So you have to always keep this thing, and you have to also make ensure that mod Cn square upon mod Cm square will be between 0 to 1. So after this time, your psi t will be orthogonal to psi 0, means after this time, your state will be perpendicular to each other. And one more thing, you have to also learn what will be time evolution of probability density. So in the prime time evolution of probability density, the kit will not work. You have to just go for the mod psi t, psi star psi t. This will be your time evolution of density. So time evolution of mod psi t square. And if you will see that this thing will be easily written as mod phi n square, here's mod Cn square plus mod Cm square phi m square, mod phi m square plus 2 times, and you can just take the real part of Cn star Cm, and here you can have cos value, and you have En minus Em T upon h cut. So you should remember this formula. We have derived all this thing, and we have also one particular thing, after what time mod psi t square will be in the original state. So this will also work, that you can have En minus Em into T upon h cut is equal to 2 pi. So this thing you can also work with yourself. This is very important. And sometime they can ask you what will be probability that psi t is in psi 0 state, that psi t is in psi 0 state. So obviously you have to just go and calculate this particular thing. Psi t you know, psi 0 you know, and you can take the mod square, and here psi 0 you can take, and obviously try to always make it normalize. So always make it normalize. always make it normalize. So if you are making it normalize, there are very few chance to do the error, and always you have to focus on this particular thing. These things are little bit on the upper part of your syllabus. Maybe they cannot ask this thing, but yes, they will surely ask how you are going to calculate the expectation value of energy from the postulates 1 to 3, how you can, the time is going to evolve. Up to this, you can easily calculate each and everything. So please focus on this thing. Just go to your copy, revise the thing by just, you can just revise each and everything, keeping in mind that are you missing these some points or not. These videos are not enough. These videos are only for you, such that you can focus on that thing at that time of examination. At least you have to revise all this thing once, okay, and that will surely create some difference. Okay, so just try to do it with yourself. Just try to start revision of quantum mechanics. Thank you, students.